Hi, this is Christy Patton-Lukes for the first content video for the Chemical Engineering Material and Energy Balance course. So, unfortunately, there we go, that screen is advancing. We're going to look in this one at engineering calculations. I am doing this as a review. If you're not comfortable doing this, you probably need some more practice. And this is going to be a very quick review. So a lot of times we're going to have to do unit conversions for problems that we'll do in the future. A lot of times we've got tools that can do this for us, and so people feel like they shouldn't have to learn how to do this. You know, our calculator will do it, Excel will do it, there are web tools that will do this. But you still need to know the process, because you will be asked to do it on an exam where maybe you don't have the tool available. Sometimes there are unique units. So as an engineer, you need to know how to do this, not just simply be able to get the answer. So first, what's the difference between a unit and a dimension? Okay, so dimensions are things like the length of something, the mass of something. Those are going to be very important because they are an overall concept of what it is we're trying to measure. The unit is very specific. Here in the U.S., most of us report our height in feet and inches. But if we lived in many other places, most other places, we would describe our height in terms of how many centimeters tall we are. So the units matter. And so often people just simply say the number without the unit. And that's meaningless, because then you talk to someone from another culture or where they use a different set of units and they don't know what you're talking about. Okay? So we want to always be sure that we are talking about units to describe our dimensions, and that we always include the value with the unit. Okay? Now, I have a very strict policy in engineering courses. If you do not include the unit with your numerical answer, then it just doesn't count. You may as well have not bothered writing an answer. So be very careful about this. Inside the cover of the textbook, there's a listing of some of the most common conversion factors. I have a handout available on my web course for this, and you can use that one. There's all sorts of other things available. Now, as far as how to do the unit conversions, I am assuming that you have seen this and basically learned how to do it, and we're just doing a review. Now, if this is not the case, there's an awful lot of tutorials available online. Some of them are something to read through with worked examples, and others are tutorial videos where they talk you through and show you the step-by-step. Khan Academy had like 30 of these videos when I last looked. So we're going to do an example, and I'm going to do one with made-up units so that we can't just check it with our calculator. So here's my first example. I'm trying to purchase a rug from an online store, and I want to know if it's going to fit in my room. So this rug is listed as being 58 glyphos long. Now I have no idea what a glyphos is. I look on the website and it says it's a unit of measure that's 13.6 centimeters long. So what I want to know is what's the length of this rug in feet, because I know the measurement of my room in feet. So what I'm going to do is I'm going to simply start by taking the actual measurement. So whatever it is, 58 glyphos in this case. And then I go through everything I know and I look for quantities that equate to being multiplying by 1. So 13.6 centimeters is 1 glypho. So 13.6 centimeter per 1 glyphos. This is equivalent to saying 1. They are equal to each other. So two things that are equal to each other is equivalent to multiplying by 1. Now the glyphos will cancel, leaving me now with centimeters. But I want this in feet. So the unit conversion I remember is that there's an inch for every 2.54 centimeters. Again, the centimeters cancel, leaving me with inches. And a foot is 12 inches. Again, the units cancel, leaving me with only feet for the units. I take 58 times 13.6, divide by 2.54, divide by 12, and I get 25.9 feet. Now this might fit in my room, but that's a fairly large rug. So I found a second rug. Now this one said it's going to cover an area of 109 glyphos squared. Again, not comfortable with this, so I want to find out what's the area of the rug in foot square. So again, same unit conversion, let's look at doing this. So 109 glyphos squared, well, a glyphos is 13.6 centimeters. This cancels one of them, so therefore I need to square this quantity to cancel the glyphos squared, leaving me centimeters squared. Now an inch is 2.54 centimeters. Again, squaring this will get me square inches. And 1 foot is 12 inches. Square this, and I end up with feet square. So when I do the calculations, I'm going to get feet squared as the units. But for the number, I'm going to take 109. The units were already squared. These are inside parentheses, so I'm going to take 109 times 13.6 squared, divide by 2.54 squared, divided by 12 squared, will get me 21.7 foot squared. A couple of other little things about systems of units. First of all, in this course we're going to use both SI and American Engineering systems. American Engineering is often called English units, but the English have long since gone over to SI. Americans were the only ones that still use this, and in engineering throughout the world you will still find these systems of units in use. So we need to be comfortable with both of those. Now a lot of times SI units are indeed easier to work with, so that's great. Work with those if you feel you need to. But I'm going to tell you, if an answer or if a problem is stated in a certain set of units, the final answer should be in those same sets of units, regardless of whether they specify that, oh, be sure to use American Engineering units or be sure to use SI units. So your intermediate steps, if you wish to switch everything over from one set to the other set, work with it. Just remember at the end to switch back. Okay? Now, I personally recommend the minimum number of unit conversions. So just get used to doing American Engineering if that's what the problem is stated in, or SI if that's the case. Now, numerical calculations. Again, I am treating this as if you have had a course, an introduction to engineering kind of course. So you should know rules for using scientific notation. You should be somewhat familiar with significant figures, or I'll just call them sig figs. Okay? Read this part of the book carefully if this is not familiar to you. I personally find that physical measurements that are made with more than 3 significant figures require a great deal of effort, a great deal of money to purchase the equipment to do those measurements. So in general, most engineering calculations should never have more than 3 significant figures. So when in doubt, what I recommend, throughout my steps of the project, doing all the work, I carry all the significant figures that my calculator or worksheet, spreadsheet, whatever will work with. And then at the very end, I'm going to reduce it down to 3 sig figs. Okay? Because that's realistic. Now there are instances where we are doing some very high-level work where we can get more sig figs. In those cases, I need to be careful to carry through and make sure that I really do know how many digits are appropriate. Okay? So, again, rule of thumb, engineering calculations, no more than 3 significant figures. Another thing that I'd like to cover with you at this point in time is estimation. A lot of times engineering students are very bad about just relying on their calculator, their computer, and they give you an answer and you just accept that. Sometimes you made a very simple-minded mistake. So in that problem we just did with the rug, and I said that this rug was going to be 25 feet, I knew that that was like, okay, well, that would fit in a very large room. It wouldn't fit in most rooms, not the ones in my house for certain. So I have a mental sense of the size. So I really do recommend that most problems, take just a moment to picture in your head what the size of the object is. Okay? In other words, think, if you have to buy 100 bottles of water, and they're 1 liter bottles, will they fit in the trunk of your car? Probably, unless your trunk is very messy. But if I needed 1,000, okay, now I'm really starting to worry. I may need to get a bigger vehicle than my car. So be able to think through the size of things. I want you to start as we work problems. Most of the problems in the book are realistic. And so some of them are going to be for small bench scale equipment. Some of them are going to be for things that are industrial. And you should be responsible for beginning to get a sense of what size this equipment is. What flow rates do we really use going through equipment? Start getting used to the magnitudes of our answers. Finally, what I would like to address in this video is just a reminder that you can't add or subtract things that don't have the same units. Okay? Now, there's always 5 apples and 3 oranges means you have 8 pieces of fruit. That's correct. Okay? But you had to change those units in order to get to that answer. So, if you're going to add or subtract things, they have to have the same units. Now, multiplying and dividing, you just keep all the units, and if they happen to cancel, that's awesome. We then run into things where we have transcendental functions. Now, maybe you remember what transcendental functions are from your math courses, but if not, these are usually things like sine of x, cosine of x, log of x, exponential of x. Anything where the function is in the exponent, those are going to be transcendental functions. Okay? One of the things that engineering students most often lose track of is that the argument of a transcendental function has to be dimensionless, and the answer that they get when they do the calculations will be dimensionless. Now, as a result, this is why when we're doing trigonometry, we always use radians and not degrees. The radian is dimensionless. Okay? It's the ratio of 2 lengths, and so therefore it doesn't carry units. But a degree is a unit, and we have to carry that with us. So in engineering calculations, we prefer to use the radian. That way, as I do my math, I don't have to worry about units. So now for some little quick practice. You might want to pause this, think about this, but what are the units of the number 30 that we see in this equation? Okay, now p is in bars, it's p to the minus 1 power, or 1 over p. It's equal to 17 times t minus 30 to the 4th power. So take a moment, try and come up with the correct answer. Alright, so t is in degrees C, therefore if I add or subtract, the quantities in parentheses are subtracted. If this is degrees C, 30 must also be in degrees C. So what about that number 17? All right, this one's a little trickier, but this is degrees C. We've already agreed that this will be degrees C. So this is going to have degrees C to the 4th power. This is 1 over bar. So I can multiply, divide. So if I divide both sides by this grouping to get 17 all by itself, that's one way to do it. Okay, I have 1 over bar already, and now I've divided through by degrees C to the 4th power. So it's 1 over bar per degree C to the 4th power. So again, answer 3 is correct. And finally, challenge yourself by reading these statements and coming up with which ones are true. Again, take a moment, pause the video, and we'll come back. Okay, so the first one is true. A dimensional quantity cannot be added to another dimensional quantity unless the units are the same. Statement 3 is also correct. A dimensional quantity on one side of the equation has to have exactly the same units as the dimensional quantity on the other side of the equation. But statement 2 was false. A dimensional quantity can be multiplied by another dimensional quantity with different units. You just simply divide or multiply those units. And the fourth one is also false. A dimensional quantity can be the only term in an exponential. That just is simply false. All transcendental functions, the exponential function is one of those, must be dimension-free, and again, the answer will be dimension-free. So in the next video, we'll continue to look at our introduction to engineering calculations. Thank you.